Imagine walking into a dense, overgrown forest, or the chaotic aftermath of a disaster. To a human observer, the environment is overwhelming. You see fallen trees and twisted metal and endless layers of earth. But any specific physical evidence hidden within that landscape is lost in the noise. Our eyes look for recognizable shapes, and when sight fails, we bring in technology. But even advanced ground-penetrating radar struggles when the terrain is highly uneven, saturated with water, or filled with dense debris. The physical search hits a dead end. This is where investigators bring in a specialized canine, a human remains detection, or HRD dog. These dogs navigate a three-dimensional landscape constructed entirely out of invisible chemical compounds, mapping the environment through smell rather than sight. To understand how they locate what we cannot find, we have to examine the precise mechanics of scent. This data visualization compares human olfactory biology to a dog's. While we rely on our visual cortex, a canine's nose contains hundreds of millions of specialized scent receptors, allowing them to detect odor concentrations at microscopic levels. That receptor density acts as a biological filter. It allows the dog to ignore the environmental smells of damp soil, rotting vegetation, and local wildlife, keeping them locked on to a single target. That target is a specific, evolving chemical signature made of volatile organic compounds, or VOCs. As biological tissue breaks down, it constantly releases these chemical gases into the surrounding environment. This chart tracks the hundreds of different VOCs released during decomposition. The specific mixture changes as time passes, but sulfur-containing compounds remain highly active and consistently present throughout the process. Researchers refer to the discrepancy you see here as the sulfur gap. Some synthetic training aids fail to accurately replicate those persistent sulfur markers, meaning a dog trained only on artificial scents is working with an incomplete chemical profile. To solve this, forensic handlers use a method called matching to sample. In a controlled environment, the dog is challenged to compare a target scent with multiple alternatives, rewarding them only for an exact chemical match. Canine biological hardware requires these mathematically precise, standardized training protocols to yield reliable forensic evidence. Out in the field, putting that training to work requires a structured search strategy. Handlers systematically guide the dogs through grid patterns, calculating their routes based on the local topography and terrain. Airborne scent behaves like smoke. It travels dynamically across the landscape, pooling in valleys, rising with temperature changes, and reacting to ground moisture. Because of this dynamic movement, handlers work their dogs directly into the wind. This ensures the airborne VOC traces are carried straight into the dog's path. Once the dog intercepts that invisible plume, they trace the chemical gradient backward, sweeping back and forth to find the point of highest concentration. When they pinpoint the source, the dog executes a trained final response. Instead of digging or barking, the dog simply sits or lies down next to the target in a passive alert. That passivity is a forensic requirement. The target might be microscopic traces of blood or deeply buried remains, and a stationary alert ensures the dog doesn't disturb the site. Even with advanced training, HRD dogs are susceptible to environmental interference. High heat, heavy rain, and unpredictable winds can all skew a search and lead to missed targets. Because of these variables, an alert from a dog is directional rather than definitive. They filter out acres of empty land to tell human investigators where to focus their resources. Once the alert is registered, the investigation shifts to methodical tools. Teams bring in ground-penetrating radar, soil analysis, and specialized measuring equipment to confirm what the dog's nose detected. This combination of biology and forensics applies to historical and archaeological discovery as well. Researchers deploy them to forgotten battlefields, historical cemeteries, and marginalized burial grounds where written records are incomplete or missing. The partnership between canine biology and human methodology decodes chemical traces to identify burial sites and crime scenes that visual evidence can no longer reveal.